This honey here contains the deadliest neurotoxin ever discovered. The bacteria that exist in the honey to create the toxin, however, are not dangerous because they're in their protective spores. The bacteria is anaerobic, meaning it survives in low oxygen environments, and when the environment isn't suitable, it surrounds itself with protective membranes. So the honey is completely safe to eat, except infants should not be given the honey because their underdeveloped intestine cannot destroy the bacteria. This dangerous bacteria is called Clostridium botulinum, and it doesn't only live in honey. It colonizes soil, marine sediments, and the intestines of bird, fish, and mammals. This bacteria can be found almost anywhere. But what makes Clostridium botulinum really worth the attention is its paralyzing toxin. This toxin at the least amount will take about 1 nanogram per kilogram of weight to be lethal. A nanogram is 1/1,000,000th of a gram. Imagine cutting a paperclip into 1,000,000 pieces and only having to adjust a few of those particles to be in danger. The molecular structure of the toxin is key to its effect. A molecule of botulinum toxin is composed of one heavy and one light amino acid chain connected by a disulfide bridge. The heavy chain is 100 kilodaltons, or 100,000 grams per mole. The light chain is 50 kilodaltons. For the toxin to take effect, the molecule must bind to and enter the nerve ending. The heavy chain is responsible for binding. The light chain is the toxic portion that must enter the cell. If the disulfide bond is broken, then the molecule has no toxicity. If the light chain has successfully entered through the neuron membrane, then the disulfide bond is split and the toxin enters the cytoplasm. Then the toxin splits proteins in the cell responsible for letting acetylcholine vesicles fuse to the cell membrane and be released. Acetylcholine is responsible at the neuromuscular junction, or synapse, to bind to the receptors of the muscle fiber and send an electrical pulse, which will cause the muscle to contract. Without this chemical, there is no communication between the lower motor neurons and the muscle fibers they are responsible for. The skeletal muscle no longer receives the signal to move and becomes paralyzed and flaccid. Despite the deadliness of botulinum toxin, the medical field has been making use of its paralyzing effects for decades. In the 1970s, the toxin was first used medicinally by ophthalmologist Alan Scott and has since then been mostly used to treat muscle overactivity. Needles delicately inject the toxin in minuscule doses into the overactive muscles. To avoid the patient building a tolerance by producing antibodies, injections are given as little as possible. Botulinum toxin has 7 serotypes labeled A through G, and serotype A is most commonly used in clinical operations. If a patient builds a tolerance to toxin A, serotypes B, C, and F can be used. The paralyzing effects last about 3 months. During that time, the toxin wears away until the disorder that was being treated starts to show more symptoms again. Some examples of movement disorders treated by botulinum toxin are spasmodic torticollis, which is when the neck jerks left, right, up, or down uncontrollably, laryngeal dystonia, which is where there are spasms in the larynx or voice box causing changes in voice and/or difficulty speaking, and hyperhidrosis, where there is excessive sweating from overactive sweat glands. As you can see, the toxin is useful in a broad spectrum of muscles. The medical field is continuing to stretch the uses of the toxin. The toxin may act as a painkiller, as patients who have received injections for muscle spasms also reported having less pain. Several studies have tested using the toxin to reduce the effect of migraines. Over 18 months, participants were given injections into the pericranial nerves. The toxin reduced the number of headaches, muscle tenderness, and the severity of the migraines, especially as the effects were observed in longer time periods. Using the toxin as a painkiller instead of other medications reduces bad side effects and the chance of building tolerance. There is also evidence that using the toxin to paralyze muscles around wounds may help the healing process. When a wound heals, the muscles around it may begin to contract from inflammation in the body's metabolism. This contracting can worsen scars, but can be avoided with post-operative botulinum toxin injections, which will paralyze the muscle. However, this is not a common practice and has only been observed in studies with small groups of participants. There is also great potential in the engineering of botulinum toxin to help prevent and treat botulism, the disease caused by the bacteria. The toxin may be used eventually to develop a vaccine. The different serotypes will hopefully be helpful in exploring diverse uses for the toxin. As you can see, the world will find a use for even the most deadly things, and the future of medicine will hopefully find new roles for this amazing bacteria and its nerve-wracking effects.